Hello guys, welcome back to my YouTube channel. Before that, don't forget to subscribe, like, share, and comment. Thank you. Hello guys, my name is Devika Kasribier. I am from Information System 2019 of University Samratulangi. Okay guys, we will discuss about graph theorem. For the first, what is graph? And for the second, we will talk about crossing number problem.
What is graph? A graph is a picture designed to express words, particularly the connection between two or more quantities. A simple graph usually shows the relationship between two numbers or measurements in the form of a grid. If this is a rectangular graph using Cartesian coordinate system, the two measurements will be arranged into two different lines at right angle to one another. One of these lines will be going up, the vertical axis. The other one will be going right, the horizontal axis. These lines, or axes, the plural of axis, meet at their ends in the lower left corner of the graph. What is a graph? In math, a graph can be defined as a pictorial representation or a diagram that represents data or values in an organized manner. The points on the graph often represent the relationship between two or more things. Here, for instance, we can represent the data given below, the type and number of school supplies used by students in a class, on a graph. We begin by counting each supply and representing the data in particular colors in a systematic order in a table. Both of these axes have tick marks along their lengths. You can think of each axis as a ruler drawn on paper. So each measurement is indicated by the length of the associated tick mark along the particular axis. A graph is a kind of chart or diagram. However, a chart or a diagram may not relate one quantity to other quantities. Flowcharts and tree diagrams are charts or diagrams that are not graphs.
What is the crossing number problem?
The crossing number of a graph G is the smallest number of pairwise crossings of edges among all drawings of G in the plane. In the last decade, there has been significant progress on a true theory of crossing numbers. There are now many theorems on the crossing number of a general graph and the structure of crossing critical graphs, whereas in the past, most results were about the crossing numbers of either individual graphs or the members of special families of graphs. This chapter highlights these recent advances, and some of the open questions that they suggest. What is the crossing number? Pak and Tiaf, 38, ask, what is the right definition of a crossing number? A drawing of a graph G in the plane is a set of distinct points in the plane, one for each vertex of G, and a collection of simple open arcs, one for each edge of the graph, such that if E is an edge of G with ends V and W, then the closure in the plane of the arc Greek letter alpha representing E consists precisely of Greek letter alpha and the 2 points representing V and W. We further require that no edge arc intersects any vertex point. We may now try to count crossings of the arcs. We follow SZ Eccles lead, 59, and give 4 different ways of doing this. Let D be a drawing of a graph. G the standard crossing number CRD of D is the number of pairs x, Greek letter alpha, Greek letter beta dot, where x is a point of the plane dot, and Greek letter alpha and Greek letter beta are arcs of D representing dot, distinct dot, edges of G such that x Greek letter alpha, Greek letter beta. The pair crossing number dot, PCRD, of D is dot, the number dot, of pairs of arcs Greek letter alpha and Greek letter beta of D representing dot, distinct edges of G such that Greek letter alpha Greek letter beta equals. The point here is that two dot, edges may intersect many dot, times, but contribute, only one to dot, PCRD. The odd crossing number OCR dot of D is the number of pairs Greek letter alpha and Greek letter beta of arcs of D representing distinct dot, edges of dot, G such that Greek letter alpha Greek letter beta is odd. The independent dot, odd crossing number IOCRD of D is the dot, number of pairs for Greek letter alpha and Greek letter beta of arcs of dot, D representing distinct edges of G that dot, are not incident with a common vertex, and such that Greek letter alpha Greek letter beta is odd. It is very easy dot, to see that, for dot, any drawing D of G, IOCRD, OCR, PCRD, CRD, dot, for each of these dot, crossing numbers, the corresponding crossing number of G is defined to be the minimum over all drawings of G. For example, PCRG equals min, where the minimum is over all drawings D of G. Thus dot, IOCRD, OCR, PCR, G, CRG. In particular, Pak and Tiaf ask, Problem: is it true that, for all graphs G, PCRG equals CRG, the independent odd crossing number was introduced by Tut, 61, who proved that if IOCRD equals 0, then CRG equals 0. He also proved the nice property that if D and D are two drawings of a graph G, then IOCRD mod 2. In that paper, Tut wonders whether IOCRD is equal to CRG, for all graphs G POC and TF, 38, proved the following interesting result.
Thank you for watching. Don't forget to subscribe, like, share, and comment.